Let's solve problem 13-3. A spring of stiffness 500 Newton meters is mounted against a block of 10 kilograms. The block is subjected to a force of 500 newtons, and that is a 3-4, so that's going to be 300 and 400. Determine its velocity at s equals 0.5 meters. When s is 0, the block is at rest and the spring is uncompressed. The surface is smooth. So drawing the free body diagram, we have the force of the spring going back, mg down, normal up, and then 500 like that, which has a 300 down and a 400 over. Mg and normal are forces in the y direction, add out to 0, so that doesn't really matter. Let's sum the forces in the x. 400 to the right minus fs to the left, and that is all we have. Therefore, that equals ma. The force of the spring is equal to the spring constant times the compression, and let's call that I guess s, ks, and m is equal to 10. So putting that in here, we have 400 equals k, which is 500, minus 500 times s equals 10 times a. Let's divide by 10 and we get a is equal to 400 minus 40 minus 50 s. Now we are looking for distance here. We have distance. We're looking for velocity. We've got distance. We've got an acceleration as a function of distance. We want to know velocity. Time isn't mentioned in the problem. Therefore, I'm thinking the equation a ds equals v dv. Putting that into a, we got 40 minus 50 s ds equals v dv. We'll integrate this from 0 to v, and we'll integrate this from 0 to 0.5. The integral, this is 40s minus 25s squared from 0 to 0.5 equals 1/2 v squared from 0 to v. So 40 times 0.5 minus 25 0.5 squared equals 1/2 v squared. So v equals 5.24 meters per second squared.